All right, guys, we're going to do 6.2 Law of Cosines today, and then you will have the rest of the class period and tomorrow to work on your 2 web assigns. If you get your web assigns done and turned in, that's fantastic. I do have a quiz review that I will make available to you tomorrow, so you can work on it. We're not going to be able to go through the whole thing on Thursday, but I'll do, as much as I can, and I'll post answers. So, pull up 6.2. This is the law of cosines, guys. You notice there's a different formula, yeah? Now, on the left-hand side, it says the standard form, and the alternative form is on the right-hand side. Notice you're solving for what in the standard form? What is A, what is B, and what is C in this case? Those are sides, all right? You use this form on the left when you're solving for sides. And then here, when you find the cosine A, cosine B, cosine C, you're solving for what? Oh, yes, you're solving for angles here. Yeah.
Can I use your calculator?
There you go. And again, guys, are you solving, on the alternative form, are you solving for the angle? When you get cosine B, cosine C, it's right here, babe. When you get cosine C, cosine B, are you getting the actual angle measure? When you solve that, it says cosine C equals. Is that the angle, or do you have to do something else to find the angle? You got to do the inverse. Yes, you have to do that cosine -1 to find the angle measure. All right, everybody see that? Got it? Okay. Now, I left this up here where it says solution because it's very important that you guys see this. If it asks you to find the 3 angles of the triangle, okay, on your quiz, it's going to say using the law of cosines or using the law of sines. But you guys should be able to recognize, why can't you use the law of sines for this first example? What do you need to use law of sines? You need at least one angle, right? You need an angle and its corresponding side. We don't have that here. So you can't use law of sines. You should be able to see that, guys, without it saying use law of sines, law of cosines. Now, once we find 2 of the angles, we can then do what?
Add and subtract.
We can add and subtract, okay? Really and truly, all you need to do is use the first step to find one of the angles, law of cosines. Then, once you find an angle measure, you could use the law of sines. So just be aware of that. But the reason I left this up here is because it says it's a good idea to first find the angle opposite what? The longest side, okay? So a lot of you want to know, where is the starting point? Where should I start? What should I do? It's best to start with the longest side. Does everybody understand what that means? So what angle am I going to find if I'm looking for the longest side? B, right? I want to find angle B. So I already put the formula right here. This is just a matter of writing everything down correctly and using your calculator correctly. If I'm going to find angle B, all right, cosine of B equals, and you need to show all of your work, guys, to get credit on your quiz. Side A is how much? 8 squared. So plus side C is how much? 14 squared minus 19 squared, all over 2 times what? 8 times 14. Yes? We good? All right, let's go through this. Simplify the top. What is 8 squared plus 14 squared minus 19 squared? 8 squared plus 14 squared minus 19 squared. What does that give me? Agreed? All right, so I get -101 divided by, what's 2 times 8 times 14? All right, so -101 divided by 224. So I get the cosine of B equals what? What's -101 divided by 224?
-4.208.
-0.4208?
No, 4.208.
You did -101 divided by 224. It's 0.4508. Do it again, Camila. Now, is that the angle measure, guys? No. So you need to do what in your calculator? Hit second cosine and plug in -0.4508. And what do you get?
116.79.
Angle C is 116.79 what? 79 what? Degrees, okay? You have to have your degree mark. Okay, so we're going to go back up and we're going to say, all right, we found that angle B was 100. Did I say C? I don't know why I changed it. Mid problem. So we found that this was 116.79 degrees, correct? Now I need to find the other two angles. You can use the law of cosines again, just solving for a different angle. You could do the cosine of A or the cosine of C. You could do that. Or what do we now have enough information to use? The law of sines, right? Do I have an angle and its corresponding side? Yes. So I'm going to use the law of sines. I'm going to say the sine of 116.79 divided by 19, correct? Equals, what do you guys want to find? Doesn't matter. Okay? So sine of A over 8. Does everybody understand where I got those numbers from and all that? Okay, how do I solve a proportion? Cross multiply. So I have 19 times the sine of A equals 8 times the sine of 116.79, right? Now I need to get sine A all by itself, so I do what? Divide by 19. So y'all, in your calculator, the sine of A is what? What's 8 times the sine of 116.79 divided by 19? You got 0.30758?
0.375.
Okay. Is that the angle measure? No. So in our calculator, hit that second sign. So -1 comes up, and I have 0.3758. How big is angle A? 22.07 what? Degrees. So A is 22.07 degrees. Yeah? All right. So now that I found angle B and I found angle A, how can I find angle C? I can add the two angles that I have together. So I have 116.79 plus 22.07. And what do I get? 116.79 plus 2207? 138.86. Okay. And then I subtract 180 minus 138.86. How much? I'm sorry. 41.14 degrees. So angle C is 41.14 degrees. Now, just to make sure you did your math right, paying attention. The longest side should be across from what? The biggest angle. The smallest side should be across from the smallest angle. Is that the case here? Right? 2207 is my smallest angle. 8 is my smallest side. 14 is the medium. Across from 4114, medium. And then 116.79 is the biggest, across from the longest side. All right, let's move along. This is a different kind of triangle. They're giving me two angles and an included side. Do I have enough information if they asked me to find the area? We did area yesterday. Do I have enough information to find the area of this triangle?
Yes.
Do I have the two sides and the angle in the middle? Yeah, okay. Just make sure you remember that. All right, so we have to solve for something in this triangle. I cannot use the law of sines because I do not have a side and its corresponding angle. But can I figure out a side and its corresponding angle? Yes. What side do I need to find? I need to find A. I have angle A. I need to find side A. So in order to find side A, I'm going to use this first formula in our standard form. Agreed? Okay, so A squared. Notice it says A squared. What are you going to have to do at the very end? Take the square root. Okay, so I have A squared equals, what's B? So 9 squared plus C squared is 12 squared, right? minus 2 times 9 times 12 times what? The cosine of angle A, which is 25 degrees. Check, just to make sure you put everything in correctly. Now, some of you are going to want to try and do everything in the calculator at one step. Some of you will be able to, some of you will not. I suggest you just take your time, simplify as you go. I would do the first part. What is 9 squared plus 12 squared?
81.
All right, 81 plus 144, so 81 plus 144 minus. What is 2 times 9 times 12 times the cosine of 25? You can multiply all that together. 2 times 9 times 12 times cosine 25.
195.76.
195.76. Give me 4 decimal places.
20 and
7624.
24.
Okay. Did you guys get the same thing? We agree?
Well, I plugged in cosine 25 and I asked
Okay, hang on then. All right, so now we can simplify a little more. What's 81 plus 44? 81 plus 144 is 225 minus 195.7624. Okay, what do I get?
29.2376.
So A squared equals 29.2376. That is not the measure of side A. That is A squared. So how do I figure out what side A is? Take the square root. All right, so side A equals, what is the square root of 29.2376?
5.407.
5.407. Okay. Now, guys, think about this for a second. If we rounded 2 decimal places, we'll say that A is 5.41. Should I have a plus or minus in front of my answer?
Yes. No, because it's an angle.
Okay, it's a side length.
Side.
Okay, it's a measurement, right? Generally, if we were just solving this problem for A, you would have plus or minus in front of your answer. But since we're talking about the measurement of length, you just want the positive, but that's good. So you guys just figured out that A is 5.41 meters.
So you do not include the plus or minus.
You do not need the plus or minus. No, you not that you don't need it. You don't use it because you don't measure length in negative numbers. Make sure you have your units. See how I put meters with it. Now we can do what, Camilo? The law of sines, because I have an angle and its corresponding side. So I can now say, all right, sine of 25 over 5.41 equals what over what? What do you guys want to find? B, okay. Sine of B over 9. Cross multiply. So 5.41 times the sine of B equals 9 times the sine of 25. Divide both sides by 5.41, right? So the sine of B, I'll do it down here. Sine of B is how much? What's 9 times the sine of 25 divided by 5.41? Okay, so 0.703. So go ahead and hit second sign in your calculator. And you found out that angle B was how much? 44.66 degrees. Okay, so angle B is 44.66 degrees. Now, if I'm going to try and find angle C, I could use the law of cosines. I could use the law of sines again. Or I could easily do what? Add the two together and subtract from?
180.
Good. So what is 25 plus 44.66?
69.68.
69 point what?
68.
Didn't you tell me the angle was 44.66?
Yeah, I don't know why I got that.
Okay.
Use your brain. Oh, yeah.
So now what? What do I do? How do I figure out what angle C is?
Subtract 6 and 9.
Okay. 180 minus 69.66. What do you guys get?
110.34.
110.34 degrees. Make sure you have your degree measure and your units. So think about this, guys. The smallest angle should be across from the smallest side, is it? Yes. Is the largest angle across from the biggest side? Yes, you're good to go.
Question.
Uh-huh. Now, like with the law of sines yesterday, remember we had to keep checking for the ambiguous case? There is a possibility of an ambiguous case with law of cosines. It's just very small. The way that you would have that is if they give you two sides and an angle. Where is the angle located in this scenario where it's like that? Where is the angle located here? In the middle, in between. Where is the angle located here? Okay, that's the only time that you could possibly get the ambiguous case. On your web assignment, they do not give you the option of entering two triangles. So if you get a case where you know you did your work right, you know you rounded correctly because it asked you to round, but it's saying it's wrong, check to see if it's a side-side angle scenario, and there might be a second triangle, but they don't give you the option to enter two triangles. On your review that I give you, I promise you I'll give you that option. But you just got to check. All right, here's a word problem. I did not choose this. This came from the book, but the pitcher's mound on a softball field is 43 feet from home plate. The distance between the bases is 60. As shown in the figure, the pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound to the base? So here is the picture. Okay, here is the picture. Here's the triangle. I want to know how far, what's the question? How far is the pitcher's mound from first base? So we are looking for this. Does everyone understand that side we're looking for? Is that true? No, come on, pay attention to what I'm doing. I want to know how far the pitcher's mound is to first base. Right here. That's what we're looking for, H. All right, we're looking for H. So how do I go about doing this? Can I use the law of sines? No, I have to use law of cosines. Am I looking for an angle measurement or a side length? A side length. So what formula would I use if I'm looking for a side length? The standard, right? Okay, so I'm looking for H. I'm looking for H, and it'll be H squared. So what would I fill in? What's my formula? Come on, guys, you should be able to go back to the last slide. So what would it be? Tell me what to write down. 43 squared plus 60 squared, good. Minus 2 times. Is it sine or cosine? Cosine of 45. Now, Becky just asked a good question. How do you know which formula to use? Because there's different letters. If you don't have a given triangle that has your A, B's, and C's, you're just looking for one specific side. In order to use the standard form of the law of cosines, you need two sides and the angle that's in the middle. So that's all the information that you need. Now, guys, just be careful. Just be careful doing this. If I were you, especially as we're just now starting to do this, just simplify in pieces. What's 43 squared plus 60 squared? What's 43 squared plus 60 squared? 5,445, yeah? 49. Minus, what is 2 times 43 times 60 times the cosine of 45? If you need to do it a couple times in your calculator, do it a couple times. Just make sure your fingers can key it in correctly. 3,648.67? Okay. So now simplify that. What's 5449 minus 3648.67? You got 1,500, 1,800, 1800.33. Okay. Now I need to know how far the pitcher's mound is from first base. Does it make sense that it's 1,800 feet? Even if you've never been to a softball game in your whole entire life, you should know that that's a very long throw from the pitcher's mound to first base. So what do I have to do? Take the square root. So h equals, what's the square root of that? All right, 40 what? 42.426, so 43 feet. Camille, if you're getting error.
Yeah, I messed it up.
Okay, did you fix it? Okay. Now, does that make a little more sense? That it's for about 42, 43 feet? Yes? Okay, good. So there's a real world example where you had to use the law of sine, the law of cosine, something like that. Okay. All right, now we're going to talk about Heron and his formula. Okay. This is the formula for Heron's area formula. Now, you guys were given you already have two area formulas. Area is base times height divided by 2, right? Then yesterday we had the two sides, right? Two sides multiplied by each other. And then what did we have to do? So in this case, guys, this is a different formula because you have a different kind of triangle. All right? Heron's formula is the square root of s times s minus a, s minus b, s minus c. All those a, b, and c are the sides. And the way that you calculate s is you add the three sides together and divide by 2. The reason that you have to use this formula, can you use base times height divided by 2 for this triangle? No, because you don't know what the height is. Can you use the area formula that has you use two sides and the included angle? No, because you don't have an included angle. So here you would apply Heron's formula. So the first thing you have to do is find out what S equals. S is A plus B plus C divided by 2. So I have 53 plus 43 plus 72 divided by 2. If you want to do that in your calculator all at one time, you need to put the numerator in parentheses. If you don't, your calculator will divide 72 divided by 2 and then add it to the other numbers. So you have to tell your calculator, hey, add everything on top, then divide by 2. If you want to just simplify the numerator, then hit divided by 2, that's fine as well. But what does S equal? S equals 84. Now, you guys don't really need to memorize this formula. You should be able to remember it, like just in basic common sense terms. You add all three sides up, divide by 2. And then you're just subtracting, subtracting, subtracting. So you're going to take the square root. 84 goes on the outside here. And then how many sides do you have? 3 sides. That's how many parentheses you should have. So you say 84 minus one of the sides, so we'll say 43. 84 minus 53. And 84 minus 72. Now take a second to make sure that you have all 3 sides. You didn't write 2 of the sides the same. And take another second to make sure that you put the bigger number first. Because guys, when you're doing anything with area, with length of sides, with angles, should you be getting negative numbers? No. If I were you, I would just simplify underneath the radical. If you want to do all of this together, you have to use a lot of parentheses. We're going to go step by step here just so we make sure we calculate everything correctly. What is 84 minus 43?
41.
What is it?
41.
41, okay. What is 84 minus 53?
31.
Okay. And then what is 84 minus 72? Okay, simplify a little more. You're going to get a big number. It's okay. 84 times 41 times 31 times 12. 84 times 41 times 31 times 12. It is a large number. That is okay. What is it? 1 million. Come on.
Where is it?
1, 2, 8. 168. 1,281,168. And then hit second square root. Find the square root of that. What is the square root of 1,281,168? 1,131.886, so 89. And what unit are we talking about? Meters. And since this is area, it's meters what? Squared. You just should not wait until the day of and then come in and be like, oh man, I don't know how to use my calculator. I'm not going to help you. You have to show work. If all you do is just give me an answer and there's no work supporting it, I'm not going to give you guys credit. I'm not going to search all over trying to find where you were putting your work. Or it has to make logical sense. You have to show me what you guys are doing. Does that make sense?
Can you simplify like this, or can you just put it like this?
That's fine.
Like for your work?
Yep,
like,
that's fine. So here's our three formulas, right? Standard, what you guys have used in the past, it's just your base times height divided by 2. What we did yesterday was our oblique triangle. That's when we used two sides and the angle that was in between divided by 2. And then we have Heron's formula, which you have to find the S value, which is all three sides added up divided by 2, and then plug into the formula. Sound good? All right.